Okay, we are live in both places.
Good afternoon, everyone. I'm Nikhil Sharma from NASSCOM 10,000 Startups. I welcome you all on this expert session, Strategizing Data and Analytics for Startups. So I personally believe those companies that view strategic asset are the ones that survive the best. Doesn't matter how much data you have, it's whether you use it successfully or not, that counts. Quickly coming back to the session, I would like to introduce our speaker for today, Mr. Arun Srilalan Iyer, an experienced product manager with experience in Bajaj Finserv Health, and also a community member in NASSCOM Product Skills. He has a wide experience in working with brands like Pervasio, Ola, McKinsey, and UiPath. So for the audience, I request to please feel free to type your questions in the Q&A tab, and we will take your questions post the presentation. Over to you, Arun.
Thank you very much, Nikhil, and a very good afternoon to all the panelists and the participants. I hope you enjoyed the session. Today, we will be talking about how to balance the soft and hard aspects of a data-driven culture. It's probably applicable for startups as well as mid-sized companies, probably even larger companies. And as Nikhil mentioned, I'm currently lead technical product manager at Bajaj Finserv Health, which is a healthcare tech startup. And I have experience in both B2B and B2C domains, in both enterprises and startups. So I'm able to, I hope to bring about those thoughts and perspectives to make this session hopefully useful to you. Please keep it very interactive. Keep your questions, your comments and thoughts coming in from the chat window. Nikhil will be addressing them. Nikhil and I will be addressing them at the end of the session. Right? So let's get started. Here is a quick 1-minute read for you on our legal disclaimer from NASSCOM. Moving on. Okay, so let's talk about data and how does data fit into your organization, right? So we will drill down into the hard and soft aspects of data. Everyone here must have heard some bombastic, some cliched statements about data in the last decade or so. Claims like data is the new oil and hence is very valuable. How organizations try to be very data oriented and make data driven decisions. However, for any of you who have tried to set up such a culture, or even such data-enabled infrastructure in your organization, you would realize that it's definitely not easy, not just to execute an action, but to even conceptualize and to build a strategy around, right? So let's first take an overall look at what you can do in your organization with data, right? Very, very quick brief about some organizations which have managed to effectively leverage data for their benefits. So Airbnb, especially during the pandemic, and during the pandemic, the results have become visible, but the soft and hard infrastructure for building a data-driven culture was set several years earlier. It is able to figure out what are the preferences for different people who use its services, what are the locations, and what are the times of the year and day and so on that are most frequent, and can hence optimally use them to deliver better customer experience as well as better financial outcomes for the company itself. Spotify, this is a company which kind of is shaking up everything around music, probably like Apple Music or iTunes did over a decade ago. They are able to use rich data and analytics to figure out the tastes that music listeners who log into their app have, and are able to curate playlists which are extremely personalized for each listener, depending on their history, depending on the time of the day, depending on their mood, and so on. RBS, so it is not just new age technical startups that are using data effectively. Large financial institutions and banks like RBS have now adopted a very firm data strategy. RBS now has something has a strategy for personalization where they use anonymously, right? It's no human that is looking at it. It's a set of machines that is looking at data like the transactions that are performed by a customer. Where do they spend most? Are they spending on travel? Are they spending on dining? Are they spending on shopping? Are they spending on medicine, and so on? And are able to recommend the right kind of investment products as well as credit and loan products to the customers. Target, again, this is, in fact, it is one of the earliest known examples of companies that effectively leverage data. Target uses not only data in its backend, both Target and say Walmart, to be able to manage its supply chain properly and make sure all their retail outlets are fully equipped, fully staffed, and fully stocked, but also a lot of information about customers, about their purchase behavior, and be able to make customer segments and provide the right promotions, provide right product recommendations to customers. Netflix, this has probably been our crutch during the last 1.5 years of our pandemic. It's a highly, highly data-driven organization, records extremely minute and kind of quirky or unusual types of data. For example, as you would expect, it is definitely logging who. It's definitely tracking data around the users who are logging in. What is their location? What is the time duration that they spend on watching content, and so on. But you would be surprised to know it also records data on how far or how long into a video or a movie series does a person watch before they stop, or before they before they drop off. What are the different genres or different kinds of actors and directors who work together? So often, some of the productions that you see from Netflix are not what you would typically see from any other big budget production house, but they still seem to work because they have been able to put the data together and bring in that intelligence to ensure that their product, which in this case is some kind of content that consumers will consume, how would that work, right? GE, again, as I mentioned, it's not the new age startups. It's not just retail as well, banking as well as GE, which is into power and electricals. They are using a lot of consumer data as well as Internet of Things data to understand how their heavy equipment works. For example, if they are building drilling equipment, I'm just taking this as an example, or any kind of high tension power lines or that kind of equipment, they have all the rich industrial Internet of Things data to know how the different parts of the solution work together. Are there any chances of failure? And they can do preventive maintenance, which costs a lot less and brings high availability for its customers. So yes, both tech and non-tech, new age companies, as well as established enterprises have been able to transition to using data very effectively in their organizations to deliver superior outcomes for customers and for their shareholders, right? Again, you would have seen far more examples in your daily life. So this was just a quick taste. Moving on, how does the engineering pipeline or the maturity of how data is used, how does that evolve in an organization, right? So with any data, you typically start with what is known as exploratory data analysis. So this is a process in which it's like taking a first look at the data that you have been given. So you take a look to see, hey, what kind of analysis can I perform on it? Are there any interesting features or any interesting facts that I can dig deeper into? Is this data lacking something, or is there something else that I need to do to make this data complete so that I can answer a more strategic question? For example, if you want to know who are the customers who are buying my beauty products, right? Are they tier 1 urban young males, or are they tier 2 or tier 3 maybe, and maybe a senior age group kind of demographic? So how would you do this kind of initial data analysis to know whether that question can even be answered or not? So that would be exploratory data analysis, first step of the data engineering pipeline and the data maturity, right? Then you have data science, which deals with a lot of models, regression techniques, correlation techniques, and so on, to be able to make predictive statements. These are highly used by your marketing and sales department to drive promotions, to drive outreach campaigns, to drive engagement and awareness campaigns, to get better bang for your buck. That is, instead of just carpet bombing everyone in your customer base, or everyone in the whole wide world with some kind of communication about your products and services, how do you target better to increase conversions, right? So that would come with a bunch of correlations and regression models with data science. And I understand this is still at a somewhat high level. We will get into the specifics, right? After data science is where the more cutting edge or newer applications of data come in. Things like machine learning or deep learning, which essentially is used by this. So this is where the terms become a little fuzzy. And in fact, the definitions of the terms themselves have kind of varied over the last 5 years to 10 years. Machine learning is built on a bunch of models, maybe neural networks and things, which try to figure out patterns from a whole lot of data that is fed to the model. So this can be used very effectively in things like image recognition and face recognition, in things like credit card fraud detection. So out of, say, 1 million credit card transactions, maybe only 10 will be fraud. So there's a very, very low fraction that could be fraud, but the cost of letting that through can be extremely high. So machine learning and deep learning models here can help try and figure out a model or a formula by which, given any transaction, it can predict with a certain level of conviction or a certain level of confidence whether that given transaction is likely to be a fraud transaction or is it likely to be a legitimate transaction. Just as an example, artificial intelligence is being adopted more and more by all kinds of companies in areas that you would not even expect. I think the next big innovation or next big deployment that we will see in artificial intelligence is likely to be in the area of self-driving cars or automated cars, which is likely to disrupt our life tremendously over the next few years. Definitely, it is used in several other applications. And IoT or industrial IoT is basically the Internet of Things. It is where devices can now talk to each other. Right now, devices are like your phone and your laptop are connected to each other via the internet, but By and large, non-computing devices are not connected to each other. The IoT Internet of Things essentially conceptualizes a model where all the devices in your house, maybe your fridge, your TV, your washing machine, your water heater, your smart lighting system, and your door lock, everything is connected not just to each other, but also to the internet, to some kind of a service provider in the cloud. And that can enable experiences that we could not possibly imagine. You could, if you have ever done something like a design thinking case study or any kind of product management interviews, you would have come across instances where, say, a fridge can detect when the milk levels are low and when certain groceries are low, and can automatically order these things from say Big Basket, which is a grocery service, to be able to replenish these items, right? Or your smartwatch can tell the house that, hey, the person has left from their office at this time, so it can tell the microwave, please keep the pizza ready, and it can tell your water heater, please heat the water because this person wants to have a bath as soon as they come back from home. So any general kind of applications, but far more than retail applications, today the Internet of Things data and applications are being tested in the industry side, in the heavy industry side, which do not affect you and me or any of us as retail consumers, but they bring a lot of value to heavy industries. For example, in oil and petrochemical industries, the exact rate of flow, the temperature, the chemical composition of the liquids that are flowing through all the pipelines and through the oil rigs and stuff are constantly monitored and constantly being adjusted by sensors and by actuators. All of this data is flowing at a tremendous rate. So, several gigabytes or terabytes of data per minute are being generated and being processed and analyzed in real time to make minor adjustments, to make continuous adjustments throughout the day. It is definitely used in things like airlines and travel, where there is again gigabytes of data being generated about every single flight that is happening in the world at any given time, and is being sent back to the centralized servers to optimize flight routes, to optimize fuel consumption, to keep to take care of any safety hazards and so on. So industrial Internet of Things is probably how Internet of Things will start and then move into the retail spheres, into your house, into our houses, right? So this is how the data engineering matures, goes from a very initial exploratory kind of form through data science, which is regression and correlation models, which are trying to optimize your click-throughs, effectiveness of campaigns, targeting, and so on, to further higher-end data applications like machine learning, artificial intelligence, and Internet of Things, right? Now, in any of the training sessions or any data models that you would have looked up on the internet, you would generally find something like, say, DMAIC, define model, something. I'm forgetting some of the terms. However, at a very, very broad level, it's just like what we talk about in computing in general, that you have input, you have processing, and you have output, very, very standard process. This has been going on for decades and decades. Very similar to this, you have the data engineering model, where you have to procure data, which is similar to input. You prepare the data and then consume the prepared data in whatever form you want. Now, why are these contrasted or placed next to each other? Because there are some very important lessons that we can get from this general data engineering model. Now, imagine that somebody is asked to write a mobile application, or just a desktop application, right? A program, right? Would it make sense to ask the engineer, hey, show us what you can make, and then we'll tell you what you want? We won't even tell you whether we want a game, or whether we want an SAP kind of ERP application, or whether we want an accounting application. You show us what you can make, and then we'll tell you what we want. This just sounds nonsensical, right? The input in any kind of general process, any kind of general programming process, is determined by a pull from the output. You first determine what you want, and that determines what kind of inputs are required and how that will be processed, what will be the application architecture, and so on. That translates directly to the data engineering model. However, very unfortunately, a lot of organizations, both startups and large enterprises, seem to miss this point and tend not to think in this way. They often ask the data engineer, what kind of insights can you give me from the data that you have, right? That's like asking, what can you build? And then I'll tell you later what I want. No, it's a pull model. So long, if you can tell the data engineer that this is the kind of report that I want, or this is the kind of marketing campaign that I want to run, or this is the kind of output that I want, which is I want to build a face recognition algorithm so that people don't have to sign in to my app, or let's take it even further. I want to build an automated car algorithm so that my car doesn't require a driver, so that even people who don't know how to drive or children can drive my car, right? So that's a very, very broad problem statement. It's large enough to start several companies. The point I'm trying to make is, once you know how you're going to use the data, that is when the data engineer can figure out what data is to be procured and how it is to be processed or prepared. And for several historical reasons, and for just the fact that people don't understand data engineering very well, organizations often tend to say, hey, you get started and I'll tell you what I want to do later. In general, it cannot work that way, right? Similar to, again, software engineering, software development lifecycle, or agile models, the reason all of these software development models have come into place is that we determined as a community, as a product development community, that issues always occur. Systems can fail, humans can commit human error. So there are always going to be issues in any kind of development and deployment of any kind of software. However, detecting and fixing issues earlier in the life cycle, preferably during the design phase or during the strategy phase, is going to be much cheaper and much easier or much faster to execute than if the bug is or the issue is detected and fixed later in the software development phase. So in implementation phase, it's definitely more expensive than design phase. But if it is post rollout, if an issue is detected and needs to be fixed post rollout to customers, it can be extremely expensive. This is not just in software. This is definitely in manufacturing and pretty much any kind of process. Imagine the kind of recalls that automobile manufacturers like Toyota had to do over the last decade or so. Why? Because some issues were not caught during the design or the implementation phase. These issues went out into the final product to the customer's hand, and then when the company realized that an issue exists in production, they needed to do a recall, which is a very expensive process, right? Similar to that, in data engineering, the earlier in the process that issues can be identified and fixed, the cheaper it is and the faster it is to actually deliver and maintain. And when it becomes later in the process, so after data has been consumed, say once a report has been generated or once a marketing campaign has been finalized, now if an issue is found in how the marketing campaign was defined, or how the report format needs to look like, that can require a lot of manual effort, maybe several days or even weeks of work to rework the report before it can come into the final consumption form. So similar to any kind of data engineering model, the inputs and processing are determined by the output, and errors and issues are better fixed early in the process rather than later in the process, right? Now, let's get down to brass tacks. So these were some basic principles that we spoke about. Let's get down to brass tacks of how you store and handle data, right? What are some of the sources from which you can get data, right? Unfortunately or fortunately, the most common source till date still remains Excel files. You might get data that is an Excel file dump of some kind of a customer survey. That could be some kind of data that is captured by your sales team or by your supply and vendor teams and is being captured in an Excel file. It could even be data that is possible to be consumed from a tool, but is dumped into an Excel file just for presentation. What do I mean by that? Say people are using Jira or some kind of ticketing system tool. Often the output of that, though it can be read directly in Jira, is often imported into Excel, and then some manipulation is done, and then that is presented in a presentation, maybe to senior management, right? So Excel, for whether you like it or not, become familiar with it. Make sure that all your database sources can handle Excel input in all its different formats. Salesforce and Google Forms, you often have forms that collect data, and these endpoints like the Salesforce.com or Google Forms or any other kind of forms can directly make entries into a database. That could be a SQL kind of relational database, or it could be a NoSQL MongoDB kind of non-relational database. We will come to that in a moment. However, these tools, which are forms that collect data, it could be a form for example, a customer who is filling out a form request for insurance, or someone who wants a quote for a service or a product and fills out some details and says, hey, I want a quote for this. So this could be captured in a Google form or a Salesforce form, and then could be entered into a transactional database. Right. A third very important and often overlooked source of data is unstructured input, voice, text, and media. Right. This is overlooked for understandable reasons, but not pardonable. What do I mean by that? You can reach out to your customers, or you can have a focus group discussion with your customers to understand how they use and perceive your product. Right? The happiest customers or the angriest customers might not leave any input or output for you to be able to process via a database. Let's take the example of, say, Google reviews for any app, right? Google Play Store reviews. So most of them are either 5 stars or 1 stars. Very few people rate 2, 3, or 4 stars, because people are either very happy or they are angry with the product. Even among those, among less than 1% actually take the time and effort to come and leave a review. Mostly, if people hate your product, they'll just uninstall it and not think about it anymore. If people like the product, they really need to be delighted to come to Google Play Store and actually leave a review. Otherwise, they might be fairly happy. They might continue using your product, but might not tell you much about it, right? So it's very important to listen to those who do, the 1% of the disgruntled or the delighted customers who have taken the time and trouble to come and leave text input on Google Play Store or any kind of store or any kind of form. Voice input definitely from customer service, or as I said, from focus group discussions or interviews with customers. You get a lot of data which needs to be managed and handled before it can become actionable along with everything else. Media, again, it could be something like videos that people may do a video review of your product and service, maybe an unboxing of the new Apple iPhone or something like that. And how can you use this kind of unstructured input and get valuable insights from it? This often is overlooked and underappreciated. However, this is probably the most valuable input. Everything else, in a way, is generated by a machine. You might be generating reports from some kind of database and putting it into Power BI or putting it into some kind of reporting tool or PowerPoint. You are getting reports or you're getting data from some team in Excel files. However, this is literally the voice of the customer. This unstructured input is extremely important and valuable data, right? The next kind of data is event logs. So whenever a user logs into your application or product, whenever they place an order for an item, whenever they use a product or a service, or whenever they click on a button, it's very easy now with all our software tools and capabilities to have event logs and be able to trace out the path of a user. Which buttons do they tend to click when they first log in? What are the products and services that get the most traction? This will help you define your investments. Where do you want to put in more time, money, and effort and grow a certain part of the business, and another part of the business that probably users aren't using very much or they are not interested in? You can take a call to make a strategic decision and shut it down. Right? Transaction entries, again, these are for purchases and orders. Consider some kind of an e-commerce website like, say, Flipkart or Amazon. They definitely keep a huge database of all the transactions that are made on their platforms. That gives them valuable information about where does the customer put their money, right? Customers may click several things on your website or on your product, and they might explore a lot of places. But finally, placing an order and paying money gives you a lot more commitment information from the customer than any of the other event logs or any other kind of clickstream data, right? So these are some of the sources of data that you can use to drive insights and analytics, right? Now, what are the different kinds of data that you would want? As you can see, there are three words on screen: breadth, depth, and richness. Breadth refers to the number of columns roughly in a table that you would want before you would start doing any kind of analysis, right? There's no hard and fast number. There's no good number. I'm just giving you a kind of thumb rule. Say you have very few. Suppose for a company like Amazon or for some kind of e-commerce website, all you had for the month of June was the customer IDs of people who placed orders and nothing else. You had just one column of customer IDs who had placed orders, right? What kind of insights would you get from it? So if you have the customer IDs per transaction, that means if you had 20,000 transactions, you have 20,000 rows in a single column, you can probably do some basic analysis and figure out who is the customer who orders most frequently on your platform, who are the customers who order least frequently, and so on, right? But say you have a fairly large set of columns. You have customer IDs, you have the time of transaction, you have what was the number of items in the transaction, what was the average cart value or transaction order value, what was the gender or the demographics of the person, what time of the day did they order, and so on. If you had several columns, we could do much richer and deeper analysis of all of these different kinds of data, right? So that is breadth. I recommend having between 30 to 50 columns in a database before you start out on analysis. Again, this is just a very rough thumb rule. Take a judgment decision based on what is applicable for your situation. Next is depth. So once you have breadth, you need to have a fair amount of depth. So suppose you have only 20 or maybe 100 rows of data. That's really not enough to use all of these advanced data science and machine learning kind of techniques. You would want to have between 1 million and say 200 million rows, right? So between 10 lakhs and 2 crores of rows to do anything meaningful. Less than 10 lakhs becomes a situation where you might miss the wood for the trees. So you might be looking at very, very minor details, and these could be outliers in the general population. You just don't have enough data to go by. So a very small data set can hurt that way. A very large data set doesn't hurt in terms of analysis, but it's expensive to store and process, definitely very time consuming. Every analysis that you run on it might end up taking hours and hours. Whereas with say 10 to 20 million records, you can probably do it in a few minutes. And having 500 million records doesn't really add much more value than the 10 to 20 million does. So find a sweet spot where you have enough data to get the right insights and not too much data that your systems are overwhelmed without really giving you much better or more valuable insights, right? So that was breadth now and depth. Now, what is richness? So assume, so you have some columns. Now say all of the columns were essentially similar kinds of data. Say all of them are currency data. When you're running an e-commerce website, say all the 5 or 6 columns that you have are things like things about cost. What is the MRP of all the items? What is the discounted price of all the items? What is the storage cost in my warehouse of all the items? What is the supply or the cost of cost of goods or cost of procurement of the goods of all of these items? What was the original raw material cost of all of these items? So if they're all cost data, then there's only so much analysis that you can do as compared to the previous example where I gave several examples of different columns. So you have both numeric and non-numeric kinds of data. So name, place, animal thing is just a kind of tongue in cheek, but the different colors indicate that you have rich data, which is both numeric and non-numeric, categorical and continuous. So you, for example, gender is categorical. You have male, female, maybe trans, or you have other. You have a few defined categories in gender, but something like say age or something like order value is a continuous data type, which could have any value absolutely. So you would want to have a mix of both continuous and categorical, numeric and non-numeric kind of data, and have a rich data sets to be able to perform your analysis, right? How do you store the data once you procure it, right? So procuring data can itself be a mammoth task. Now, once you have it, how do you pick the right way to store it? You essentially, at a very 30,000 feet level, you have two kinds of data storage capabilities. You have RDBMS, that is Relational Database Management System, or Relational Databases for short. An example is something like MySQL or any kind of SQL table. And the other is non-relational, NoSQL. An example is something like Mongo, right? So let's look at how these compare. Relational databases are structured, and the advantage of being structured is that you can ensure that things don't get missed out. For example, if a doctor needs to write a prescription, they need to know the age and the gender of the patient. That's a minimum part of the structure of the prescription itself. I'm just giving you an example. Or if someone has to raise an invoice, there has to be an invoice supplier name, there has to be an invoice number, there has to be probably a GST number, there has to be a date of invoice, and so on. So there are minimum parameters that are required, and a SQL or an RDBMS table makes it easy to define that structure and to define the right control mechanisms, such that if any of these required parameters are missing, then they can be addressed, or the entry can be rejected, saying, hey, you need to provide these items first. Now, this was one of the oldest forms of maintaining data, and hence there are very sophisticated algorithms, very performant algorithms, which will do any kind of analysis, any kind of read and write operations from this data at good performance, right? So quite fast and with less memory, right? More error-free. Again, you can not only can you define the structure in terms of what is required and what's not, you can define what are the formats of all the different data fields. For example, a PAN number has a certain structure, a date of birth has a certain structure, a currency has say 2 decimal places. So all of these kinds of rules are easier to apply in SQL tables. They're also possible in NoSQL or the unstructured tables. It's just slightly harder to do, right? The disadvantage of this is that if you have once defined a table and then you find that you need to modify it, right? You need to add another column. For example, say you were taking a customer's name, and then for whatever reason you found that, hey, I need to split it up into first name and last name, just as an example, right? Now, retiring the original column called customer name and then adding 2 new columns called customer first name and last name can be very difficult. If you want to make changes to the same table, you'll probably have to add the 2 columns as first name and last name as optional columns, but then set an internal non-enforceable process where you tell everyone, hey, though this is marked as optional, it is actually mandatory, right? So there are these kind of anomalies that can happen. Say you had marked customer name, which is the combined name, as mandatory. Now that has suddenly become non-mandatory, and that needs to become blank. So changing the structure of the table in a relational database can be much harder as compared to a non-relational database, right? So let's take a look at some of the points for non-relational databases. These are used for unstructured collection. So if you, for example, if I want to understand, since I come from a healthcare background, I'm just going to take this as an example. If I want to take an example of what is the health situation or the health condition of a patient, now that could have many, many different variables. I cannot say that these are the 20 things that I want to look at. I want to look at height, weight, blood pressure, blood group, and something. They might have different allergies. They might have different medications that they're currently taking. They might have lifestyles and habits. Maybe some of them are sedentary, some of them are smokers, or have dependence on alcohol. Some of them may have past complications, maybe past infections or something, which need to be recorded into a medical sheet. So it's hard to define exactly what are the parameters that would come when you talk about what is the health condition or the health history of a patient. So an unstructured collection which lets you add and remove values as you wish from person to person. So every row does not need to have the same set of data. It's much easier to do this in a non-relational database like MongoDB, right? Which makes it flexible. However, this flexibility comes at a cost that analyzing and storing data, retrieving data from this kind of a DB can be slower than an RDBMS, than a SQL kind of table. So for very large volumes of data, if you were to have millions of records, you might see a significant difference in performance, a significant impact of storing this kind of data in a non-relational database as well, and trying to analyze it versus a relational database. Right now, because of its flexibility, it can lead to errors. For example, you might have a patient who does not specify their age, right? Or you might have some conditions where in some cases you are accepting a date of birth, which is a very good way to determine age, and in some other cases you are accepting just an age as a number, which is a fuzzy way. It's just a certain number of years, right? So it could be inconsistent data, and that can lead to further errors downstream in case of non-relational database, because it's very likely that you will define all of these as free-form text or free-form strings, and anything can be pasted into the string. More and more layers of logic are required to be applied on top of this non-relational database to control and process it better, right? So what is my recommendation? My recommendation is use both. Use them effectively wherever they add the most value, right? For transactional data, for example, if someone is placing an order on your product or on your website, use RDBMS, because the kind of columns that you want to track for every order is pretty much fixed. You can sit down, do an hour's brainstorming, or you can refer to some blogs on the internet and figure out what is the kind of data that you want to store for transactional data, define a SQL table for it, and you should be good for several years at least, right? Whereas if you have configuration data which determines what your screens of your app will look like, or what is the configuration of a product or a service, and that is likely to change not even month to month, probably week to week, or even day to day, then with this kind of flexibility that is required, a relational database will not be suitable. Use a non-relational database like MongoDB to store all of these configuration parameters, and you are free to change them as and when you like. So use them as appropriate in whichever situation it comes up with. Now, let's move on to the next step, which is data processing, also known as data munging, right? Now, this is by far the hardest step in the entire data engineering pipeline. If you talk to any of your data scientists or analysts, or if any of you are data scientists and analysts, you might, after performing a particularly hard project, you might look back and say that, hey, if I had the data in the right format, and if I didn't have to process the data so much, clean it up, bring it into the right format, bring it into a state that is ready for analysis, if I already had it in that time, if I already had it in that state, my analysis would have finished in 20% of the time that it actually took. So 80 to 85% of the time actually goes in cleaning the data, in preparing it to be made ready and suitable for analysis, right? It takes, as I said, over 80% of the time and effort in data engineering. Now, what could be some of the issues? This is non-exhaustive. This is there are far more issues, and you will run into them as you perform more and more data analysis, as you work with data in your organization, right? So incomplete data, key fields may be missing. As we spoke about in the previous slides, you could have important data, like, for example, say the order date is missing just for some reason, right? Or the location data is missing when you need a shipping address or something like that. So how do you analyze what person? So you would want to set up, as I said, your data storage structures to minimize these kind of errors by putting hard guardrails and hard rules. Remember the principle that the earlier in the process that issues are identified and fixed, the easier it becomes later in the process. So if, for example, you're using a flexible MongoDB kind of architecture to store transactional data, and you find that in some cases the customer's name is not entered, in some other cases the order, maybe the invoice ID itself is not captured, or the invoice date is not captured, you will find it much harder to process and report this data once you come to the data processing step of the data engineering pipeline, right? Data format. Now, you could have, for example, someone insisting that your name has to be a number, or your date, or your age, or date of birth has to be a string, right? which then makes it hard to figure out or hard to compute or draw insights from it. For example, if your age is a number, if your age is a string and not a number, then the machine doesn't know that the digits 3 and 4 placed next to each other are actually a number 34. It just thinks, okay, it's 34. You cannot make a bucket saying, tell me how many of my customers have age groups between 30 and 35. The system does not know that a string called 34 is part of this definition of between 30 and 35, because 30 and 35 works are numbers, whereas you could have strings. I'm just giving you very, very minor examples. There are ways to get around all this, but you will find that the more manipulation that you need to do and processing that you need to do with your data, the harder and harder it becomes to process further on and report and analyze, right? You would also have issues with how data is stored in your ticketing systems, how that is used and reported. Sorry, am I hearing someone? No, no worries. Okay. Yeah. Illogical data. So you could have, again, data like a company has a blood group, right, which doesn't make sense. So again, this kind of data would have to be cleaned and to be removed before you further process and report on this kind of data. The last is ill-defined data. For some reason, the data is not inconsistent in these kind of mathematical parameters or in this kind of logical parameters, but it is just ill-defined. For example, if I ask, how many users does my app have today? My data scientist will ask me, what do you mean by a user? If someone installed your app 2 years ago and has not ever logged in since, has not updated the app, has just not uninstalled it, it's just lying on their phone, would you still consider that person a user? What if they had the app for 2 years and used it very frequently, and just last week they uninstalled it? Is that person still a user? Right? So what you need to define what a user is in terms of time of retention, in terms of activity. Have they come back to the app at least once a month or so? So I'm just taking an example of an app. It could be any kind of data and any kind of definition. So poorly defined data makes it hard to analyze and report further down in the pipeline, right? And a good way to address that is to have what is called a data dictionary. This is a kind of spec document for a data structure or a data project, which not only defines the format of data. For example, it doesn't say, it not only defines that a PAN number is supposed to be 5 characters and then 4 digits and then a last character. It also defines what does it mean. It means it's like it's a unique identifier associated with a person or a company used to file taxes and so on, right? So the data dictionary defines each element of the data. So if you use the word user somewhere in your data table, what does that mean for your company is defined in your data dictionary. So have a data dictionary, right? Now, data engineering, much like nearly any other kind of activity that you do in your life. For example, you have a car, or you're living in a house. Is it okay to say, I cleaned my house last month and now my house is clean, I don't need to clean it anymore? No, it's a process. So very frequently, every now and then, probably at a regular cadence, you would need to clean your house, you need to clean your car, you need to do maintenance on it. A similar sort of exercise is required for data. Once it is cleaned and left alone, again, in a few weeks or a few months, data will become dirty or will become unmanageable due to various edge cases, various ill-defined things that come and sit into the data, or some temporary hacks are performed. Someone says, hey, I need this data uploaded immediately. Can you please put it in here? And then we'll clean it up later. And that later never arrives. So there is unclean data sitting in your database. All of these sort of things come, just like you would clean your house or your car or perform maintenance. Regular data cleaning and maintenance are important as part of the data engineering pipeline, right? Moving on. So those were some of the harder aspects. How do you procure data? How do you store data? How do you process data, right? And some of the tips around how you can achieve these. Now let's move to more of the organizational software, the mental thought processes, and how to build a culture and discipline of data-driven decisions and building a data-driven organization, right? There are some do's and don'ts, right? To do's and don'ts, right? So the first is to use the right set of tools for collection, analysis, and reporting tools. For example, if you don't have the right storage tool and you're saying, hey, I don't want to buy a SQL instance or something, everyone, please store all your data on Excel. Once you reach the limit of 1 million rows on Excel, just start another Excel file called V2 and continue using that. I want all analysis performed on Excel. It's going to be extremely hard. It's going to be impossible. Let me just say it outright. It's going to be impossible. You need to have the right data, right tools for data collection, analysis, and reporting. Similarly, don't ask your engineers to do analysis on Excel. Excel is not a great analysis tool. It's a very flexible tool to play around with. But once you've defined an analysis and you need to really do a lot of mathematical or statistical analysis with large volumes of data, there are other better tools like R and Python, and there are a bunch of libraries that come along with it, which help you do this, right? Similarly with reporting, and this is an example that I'm in fact facing in my current organization. When we run data ranges everything from this kind of mathematical, data org by itself, and they are working on data, to very, very day-to-day tasks and items like how do you take meeting notes, how do you run your daily scrums, and so on. And this is an example from that. The tool that we are using for using as our ticketing to keep user stories and tasks and bugs and so on, has a ticket type called enhancement. However, the enhancement ticket type never shows up in the Scrum board. For that, that's a limitation of the tool itself. Now, what is the repercussion of using this tool? The repercussion of that is that any requirements are essentially filed as user stories, right? So user stories are supposed to be pretty massive, and they're supposed to be important. Minor things like, can I change this banner image? Can I change an icon, and so on? Because they cannot be filed as enhancements because they're not visible on screen. They end up being filed as user stories. How does that hurt? When we do our final monthly reviews and weekly reviews, we find that the engineers have worked on, maybe 3 engineers have worked on 45 user stories in a span of 2 weeks, right? Which is just insane. But if you look deeply into it, most of the user stories are actually enhancements. But now that requires more and more human input, simply because the ticketing system and the reporting tool did not have the capability of viewing an enhancement type ticket, right? I'm just giving you a detailed example of something that we're going through right now. Very, very minor items like this can add on to human paperwork. So every week, my team and I have to do a bunch of paperwork to go through all of those 45, 50, or even 200 stories to figure out which of them are minor enhancements, which of them are actually very useful user stories. Why? Because my ticketing system does not allow me to work with anything except user stories. It does not allow me to view enhancements, right? So ensure you use the right collection, analysis, and reporting tools. Otherwise, the bureaucratic overhead that you add to your organizational system can be huge. There are people who have quit from my organization simply because of the amount of paperwork that we have to do due to this, right? Precisely define and track a few key metrics. When we talk about KPIs, key performance indicators, we forget the term key. And you often have organizations that report on a weekly or a monthly or quarterly basis. You have 50 KPIs, right? These cannot be KPIs. The word key means there are a handful and they represent the state of your organization. Consider, like in financial accounting, you have a triple bottom line, which says, hey, as a whole, I don't need to go into the details of what were the transactions, what are the different customer segments, which product line made more money, which one has a higher gross margin, and so on. Is my triple bottom line good or bad? Or for large conglomerates, you just have a company score, just like you have Fortune 500 or whatever. You have a company score that says, hey, this entire project or this entire program is green or red, or you can add a number. You can say, it is 7 on 10 or 8 on 10 or 8.3 on 10, right? Define that final metric such that it takes into account all of the different aspects of the project that you want to monitor. So it could be financial aspects, it could be usage aspects. So how many users are coming onto your product or service? How much money is your product or service making? How many user stories are getting delivered per week? How many bugs are coming in per user story? what is the uptime of my environment. You can assign weightages to all of them and come to a final number, or you can come to a final 4, 5, 6 metrics maybe. But precisely define and track a few key metrics for reporting. Don't report 50 metrics. It just slows down. It just Hello, can you still hear me?
Yes, Arun, we can hear you.
Is my screen visible? I think I just kind of disappeared for a moment.
Yes, no, your screen is not visible.
Right. Let me just share it again. Apologies for the interruption. Right. Is my screen visible now?
Yes.
Yes.
And Arun, sorry to intervene. So we need to wrap up quickly. We have a lot of questions coming from the
audience. Sure. Very good. I think this is kind of the second last slide we are done pretty much.
Yeah,
right?
No worries. Yeah.
So review continuously and regularly, as I was saying. Don't just define a format and leave it at that. Review continuously to drive decisions. The point of the review is just not to look through the numbers and say, hey, everything looks good. The point of the review is to figure out, okay, are we on track with what we plan to do? If not, what are the decisions or what are the investments required to move the organization to achieve its goals and targets, right? So that is how you get to keep a finger on the pulse of the organization. And as mentioned earlier, incorporate scars and valuable customer feedback as data into your database. And the last few don'ts are that don't ask data analysts to report numbers in PowerPoint, right? Define. So analysts end up saying that, I've done all my analysis. Now you want me to take all of that into an Excel sheet and then paste that Excel sheet into PowerPoint. That is just, and then make it look pretty with the right fonts and colors and things. That is just organizational overhead or reporting overhead, right? Instead, define the right reports in Power BI or Tableau or whatever kind of reporting tool, and give access to even senior management, and tell senior management, hey, whenever you want to see any kind of report, go click this link and you'll see the report in Power BI. Please don't ask a human to copy the same stuff from Power BI, put it into a presentation and manipulate the presentation before presenting it to you. It's just reporting overhead, right? This was one of the things that we mentioned earlier. Don't ask, okay, what data do you have? What can you give me with it? Start from the output that defines what data will be collected and processed. So required outputs determine what data is collected and analyzed. And don't rely solely on machine-generated information. We've emphasized this a couple of times. Verbatim customer feedback is very precious, very small in volume, but highly impactful. Make sure that is reflected in your data thinking, right? So with that, we quickly come to the end of the session. A quick summary of what we spoke about in the session. New age companies are effectively using data for competitive advantage. We took a look at some of the examples. Data engineering requires a structured approach from procurement through processing to output. Try to procure diverse types of data in breadth, depth, and richness. Make the right architectural choices while storing and processing data. We went through several pros and cons of several models. Building a data-driven organizational culture. We looked at some of the do's and don'ts that will make this exercise a success. And with that, I'm ready to take any questions. I hope you enjoyed the session, and let's have a few questions. Over to you, Nikhil.
Thank you so much, Arun. Indeed, that was a very insightful presentation and a lot of questions coming up. So I'll consider the time frame as well. So quickly, up the first question. How do we see these data applications impacting the auto industry?
the automobile industry is going through a century, once in a century kind of churn, right? Petrol prices or oil prices, essentially fuel prices, are at an all-time high. Uh, uh, Nirmala Sitharaman, our finance minister, had to say just before the COVID pandemic that the automobile industry was at an 18-quarter low in terms of business output because of whatever historical reasons, right? So there's a lot of disruption going on in several different areas, including GPS, automated, including infrastructure itself, including automated cars, electric cars, and so on. How would this data help? I'm not an automobiles expert, but I would just definitely say ensure that you do not get stuck in the old way of thinking, saying, hey, this is business as usual. We need to just do 10% better. We just need to bring another model, another car model, and just do a facelift or bring new car seats or whatever. Don't make incremental improvements. Just like say the alarm clock industry got killed by the mobile phones. The camera industry pretty much got killed by the mobile phones. If the automobile industry doesn't stay agile and up to date with the current trends in technology and data engineering, it is at risk of getting severely disrupted. I hope that answers your question.
Thank you, Arun. Coming up to the next one, for a new startup, how and when to hire a data analytics team, and how much data collection required to put the data team on work around 2,000 users?
Great question. So even 5 years ago, I would have said that your core team basically consists of 2 engineers or 3 engineers, 1 QA, 1 product manager, and that's it. Now I would add 1 data engineer that could start out as a person who owns everything about data, data procurement, processing, reporting, analytics, AI, ML, everything. Current at a small startup, that's how you would start. But ensure your data engineer is part of your initial core team when you're rolling out your first MVP, when you're rolling out your first few features, right? Now, the second part of the question was how much data analysis do you need for around 2,000 users?
Yes.
The users themselves, not too much. 2,000 is not very large. You can literally manipulate in Excel. But if there is something like you're trying to track their engagement or how many times they interact with your product, that could be several million times. There you would need a dedicated data person or a data engineer to go through all of these transactions.
Perfect. So can we outsource the data analytics team, or is it okay to set up an internal team? Which one is better?
So I would always say start with outsourcing and then move in-house. Definitely have a very, very fixed time frame for moving in-house, which is in months, not in years, right? Why do I say this? It's often expensive and difficult to hire a person with the right skill set and to train them on your data capability, or even for them to advise you on how to structure your data in the organization. So it's better to start off with an outsourced partner who can advise you that, hey, these are the right tools, this is the right architecture for your data, and so on. But I would say data engineering is as core a discipline as product management or even finance or operations. So ensure that you would not outsource your product management team or your finance team, right? You want to keep that in-house. Just like that, ensure that you bring your data team in-house within a span of 6 months or so.
Perfect. So considering the time frame, coming back to the last question, how soon should a startup introduce analytics as a part of their growth and planning strategy?
How soon should they introduce analytics as part of their growth and planning strategy? So you would introduce analytics right after you find product market fit, right? So you roll out your MVP, you might find it fails, you might find some of your hypotheses fail, you tweak it a couple of times, and then you find that suddenly things are working. Your focus group discussions, users are saying, hey, this is useful, I will buy it, or I use it every day. And your engagement numbers have started growing up. Very early, as soon as they start growing up, have an analyst start working on that, because as you scale your product, there'll be edge cases which will start detracting from the experience, which will hurt customers. There'll be issues that you can't even imagine. You will need a data engineer to help you guide through that. But until you find product market fit, probably it's more of a product manager role and an engineering role. The data engineer might not be able to help too much at that point.
Thank you so much, Arun. So, well, considering the time constraints, so coming towards the end of the session, so I thank you for bringing such an insightful information to our audience, and I really myself could not I didn't know much about how to manage data in an efficient manner. So thank you so much for. I'll follow the same tips and tricks in my BAU work as well. So.
Right.
Thank you so much, Arun. And we'll get back to you with more questions if we receive any from the founders and our audience today. And thank you so much. And you have a nice day.
Thank you very much, Nikhil. And thank you very much for the audience, your participation. I hope you enjoyed the talk. And I look forward to meeting you again. Thank you and good day.